All right, we have a polynomial with some given information. We know that it has, first off, it has a degree, oh, sorry. It has a degree of 3. It has a root of multiplicity 2 at x equals 3. So the multiplicity of 2, and it also has a multiplicity of 1. So notice that the fact that it has a degree 3 polynomial, and then we know that at one of the roots it has multiplicity 2, and at a separate root it has the multiplicity of 1. If you add up the multiplicities, that gives us a total of 3 degrees. So that we know that this entire polynomial function is made up of what is described here. There's nothing else. Because if we had any other multiplicities of any other roots, then that would go beyond a degree 3. Because you have to add up all the multiplicities to get the degree. That's just something to point out. Okay, so first, let's look at root of multiplicity 2 at x equals 3. A root of multiplicity 2 at x equals 3 gives us the root at x equals 3 tells us that we are in the form, well, first off, let's put p of x here, is equal to, now we're going to have an a out in front. We don't know what this is. That's like the last thing that we're going to be going after, that leading coefficient. We're going to solve for that last. But what we have is the root, it's x minus the root. The root is x equals 3, so 3. X equals 3, it's going to be minus that. And it has a multiplicity of 2, so that means it's going to be squared. That's the exponent that goes along with that root. Okay. Now we have to multiply that by the next root and then also the multiplicity involved with that. So we have x minus, what is the root? The root is x equals negative 2. So this is actually minus a negative 2. Okay? And then we have the exponent around the entire parentheses of the multiplicity. The multiplicity in this case is 1. Okay, so we can simplify this a little bit more. We can say p of x equals a x minus 3 squared. Okay, and then we would have x minus a negative becomes a plus, so that's plus 2, and then that's raised to the 1 power, and that's really not doing anything, that exponent. So we can leave that off, and this is what we have. But there's one other piece of information that we have. In order to solve for that leading coefficient a, which we don't know what a is yet, we have to use this last piece of information, the y-intercept. The y-intercept is y equals negative 14.4. So that gives us an ordered pair. The y-intercept is where x equals 0. So that y-intercept gives us the ordered pair 0, negative 14.4. So we can plug in the values for x and solve for a. Plug in the value for x and y. So we would have y, which is p of x, negative 14.4 equals a, and then 0 minus 3 squared times 0 plus 2. Okay, now we can solve for a. We need to simplify things a bit. So negative 14 point, kind of a weird 1. Negative 14.4 equals a. Now 0 minus 3 is negative 3, but when you square that becomes a positive 9. 0 plus 2, that's just 2, so it's going to be multiplied by 2. So that gives us 18. So that is negative 14.4 equals 18a. We can divide both sides by 18, and that will give us our value for a. So that gives us a equals negative 14.4 divided by 18. If you were to plug that into your calculator, which you should be doing, you can use the basic calculator, the scientific calculator. That will give us negative 14.4 divided by 18 is equal to negative 0.8. Okay? Plug it in your calc. You shouldn't be able to do that by, I mean, you might be able to figure that out if you do it by hand, but you should use a calculator. Don't waste your time. And so that gives us our final function, which using this form right here, we can plug in our value for a. So that's p of x equals negative 0.8 x minus 3 squared x plus 2. All right, let me know if you have any questions about roots or multiplicities in solving a polynomial function with given information similar to this. I'm more than happy to help.